All right, so hello everybody, and thank you so much for attending our CAR seminar series. I'd like to start with an acknowledgement of country. Today we are meeting across Lutruwita, Aboriginal land, sea and waterways online. I acknowledge with deep respect the traditional landowners of this land, the Palawa people. The Palawa people belong to the oldest continuing culture in the world. They cared and protected country for thousands of years. They knew this land, they lived on this land, and they died on these lands. I honor them. I pay my respects to elders past and present, to the many elder people that did not make elder status, and to the Aboriginal community that continue to care for country. I recognize a history of truth which acknowledges the impacts of invasion and colonization upon Aboriginal people, resulting in the forcible removal from their lands. Our island is deeply unique, with spectacular landscapes, with our cities and towns surrounded by bushland, wilderness, mountain ranges, and beaches. I stand for a future that profoundly respects and acknowledges Aboriginal perspectives, cultures, language, and history, and a continued effort to fight for Aboriginal justice and rights, paving the way for a strong future. So now I'd like to introduce our speakers for today. We have Manning Young, who is an admissions officer at the Department of Transport and a part-time PhD candidate at the University of Melbourne, and Dr. Amanda Wheeler, who is a senior research scientist with Oceans and Atmosphere, CSIRO, conducting research on air pollution health. So you two can take it away. Thank you so much.
Yeah, thanks. I'll just say that I'm working on roadside emissions monitoring at the Department of Transport, and formerly I was an air quality consultant, so modeling and data is sort of my area. But my co-presenter Amanda is just has tremendous knowledge of air pollution and health, and so I'm going to let her kick off with an introduction to the project and how it came about, and then I'll jump in and talk through the results.
Thanks, Emily, and thanks, Manning. So this work does represent Manning's, well, the first paper for Manning's PhD, which he's doing part-time, which I think is very brave. I'm not sure that I'd want to be doing a PhD and working as well, because it does get a lot of work. Thank you to Emily for inviting us today. This is work that we've done as a feasibility study, and we wanted to characterize and compare children's potential exposures to traffic-related air pollution, which I'll refer to as TRAP going forwards, as well as noise, on different routes that they could take as active transport routes to school from their home. And so I'll go into more detail about how the routes were selected in a later slide. We also wanted to ensure that we were in a position to develop recommendations for school communities that they could apply when they're designing these safe commuting routes. And we didn't feel like it was enough just to say, oh, this one worked, this one didn't. We actually wanted to come up with opportunities for change and mitigate exposures. So that was an important component of the feasibility work. And so this photograph shows children waiting to cross a very busy intersection in the inner west in Melbourne. And so very close exposures to TRAP, and obviously not an ideal situation for young lungs. So I thought I'd talk through the motivation behind, my interest in this and how I kind of got to this point. I'm not sure that everybody attending today has got similar backgrounds, and so I just thought it would give some context for the study. I worked for many years with Health Canada, where I did a number of personal exposure studies with children, and it was in that context that we understood that children's exposure to TRAP was actually most significant when they were commuting, and so we were able to put backpacks on children and have them carry instruments that measured their exposure to PM2.5 on a continuous basis, and from that we were able to tease out where their exposures were occurring and what was having the most impact. And obviously time spent commuting came out as a significant one, and that was published in work in a paper by my colleague Keith Van Ryswyk several years ago now. Other work that I did at Health Canada in collaboration with the University of Toronto is that we exposed, I have to admit, mostly students from the university to different size fractions of PM in the concentrator. We had access to 3 different PM concentrators at the University of Toronto: coarse, fine, and ultrafine particle size fractions, and then took a range of blood samples and urine samples. And we, identified back in 2015 that, not all size fractions impacted health equally, and the ultrafine particles demonstrated that they resulted in increased oxidative stress in the urine samples that we collected. So it was interesting to me that there was, not all PM is the same, not all PM sources are the same, but so therefore maybe not all health outcomes are equal. Going forward in time, with work that I've been doing while I was at the Australian Catholic University, was to really understand, what was happening in the school environment where children spend a lot of their day. And we were able to show through doing a systematic review, which was Chloe Stenson's work, that there seems to be a growing body of evidence that exposure to TRAP around the school is actually important for children's learning ability. And then with my colleague Alison Carver, we also got access to all of the NAPLAN data across Australia and looked at primary schools in urban areas, and identified that schools that had more TRAP in the form of increased density of road networks showed reduced NAPLAN scores. We also demonstrated that the schools that had a higher amount of green space around them had improved NAPLAN scores. And so I think that needs to be interrogated further. And I think it's an important question, I think, in terms of where we're locating schools and what can we do for existing schools to sort of change that paradigm. I was also part of the team that was funded by EPA Victoria to create high resolution spatial maps for ultrafine particles, black carbon and noise. So on the right of the screen, you can see that there are 2 maps. The top one is the spatial distribution of ultrafine particles, and the one below is for black carbon. And so this, is an interesting exercise in terms of understanding the spatial resolution and the sources, but we also need to think about exposure in terms of temporal exposures. So, is the time of day, the length of time that you're somewhere, and we also need to understand how meteorological conditions can impact your exposures as well. So in terms of, very windy conditions, that tends to cause the pollutants to disperse quite quickly. But if you're upwind on one side of the road, perhaps your exposures to TRAP will be increased as well. So there's a lot of different things that have kind of brought me to this point, and I think I just thought that would be helpful to sort of get some context around why we're doing this study. So we've focused our attention predominantly on ultrafine particles and black carbon. And so they're not regulated in Australia. And so I just wanted to give you some context for why we're interested in them. And so ultrafine particles are typically those particles that are less than 0.1 micrometers in diameter. And so typical sources fuel combustion, traffic, fast food outlets, and also through secondary aerosol formation. Black carbon is a constituent of PM2.5, although not all of the black carbon does reside in that size fraction, and sources for those including complete fossil fuel and biomass combustion, as well as diesel emissions. So data have shown internationally that, you know, the ultrafine particles, black carbon and PM2.5 measurements are not representative of each other necessarily. And so there are concerns that just by regulating the PM2.5, we won't necessarily be able to manage the ultrafine particle and black carbon as well. So to come back to the, I had just briefly in the aims had sort of talked about the paths that we were interested in evaluating. And so some of you may be familiar with the Bicycle Network. They have been working with a lot of local councils to create active paths to school. And so the active paths are created in conjunction with the school and with the local council. And so it's really sort of selected predominantly on safety for the children. They also ask the children, you know, what landmarks do you understand and know, so that they don't get lost when they're actively commuting to school. But they haven't really taken into consideration air quality and noise as part of that equation into how to select a route. And so the context for having an active path is that the children have a safe way to actively travel to school, so they can either ride their bikes, scoot, or walk to school. And so we know that there are guidance from the WHO that, you know, school-age children should engage in moderate to vigorous physical activity for at least 1 hour per day. And we know that, you know, active transportation to school is one way that that sort of habitual physical activity can be incorporated into the day. And one of our colleagues, Alison Carver, has also sort of identified that children who do actively commute are generally more active throughout the day as well. So I think the one concern is that your physical activity benefits from actively commuting to school shouldn't be offset by the negative impacts of being exposed to trap and noise. We do know that children are more vulnerable to air pollution with their smaller lung volume and the structure of their lungs. They do breathe faster, and they'd have a less developed immune system. And so, you know, we have to be considerate of the differences between adults and children. And we know that from the literature internationally that, you know, TRAP has been associated with a range of poor health outcomes, including respiratory, cardiovascular, cognitive decline, and birth outcomes as well. And so I think we just, this all kind of leads to, you know, why we feel like it's important that we should be thinking more carefully about what we're exposing children to as they develop and grow. So the study design, which is, it was, as I said, it's a feasibility study. We wanted to compare the Bicycle Network direct routes with alternative routes that we selected using Google Maps to look for the shortest route from the residents to 2 different schools in Melbourne. One of these was in Dandenong and one was in the Inner West. And so we selected a range of pollutants. I've spoken more to the ultrafine particles and the black carbon, but we also included PM2.5 with support from EPA Victoria, who were evaluating some personal monitoring devices called Atmotubes. We also included noise measures as well as measures of human thermal comfort. There's it's I think an important aspect of this work that we think about, you know, the routes that children are taking should also protect them from UV exposures and should provide them with some shade as well. And so that was an aspect that was incorporated with colleagues from the University of Melbourne. So what we did, I mean, there was quite a few members of the team, and we tried to carry the equipment to do 2 return trips along each route during the morning commute period. So usually that was 8 till 9 a.m. So all 6 routes were conducted simultaneously. And we repeated this on 3 different days for each school. So typically it was Monday, Wednesday, and Friday. We also had a background measurement set up at the school, and so that we could understand what was happening just in general for that area. And so we ended up with about 32 hours of high resolution, like 1 second monitoring data, which has, been, I think, the bane of Manning's existence, or perhaps not, perhaps you've enjoyed that, I don't know. It certainly was a little overwhelming when we looked at how much information that we had collected. So I think at this point I hand over to Manning so that he can start explaining some of their findings.
Sure, thanks, Amanda. I'll start by just illustrating those routes so you can kind of get a sense of what we were trying to achieve. So I've colored them in pairs. So on the left is the first school that we measured, and on the right is the second school that we measured in the feasibility study. And so generally the light color is the direct route, which Google Maps, the app, would send you down if you're walking. And the darker color is the alternate route, which is generally the one prescribed by Bicycle Network as a safer route. And that was just our basis for a potential low exposure route, because they're chosen to avoid major roads, which would otherwise be maybe dangerous for children. But I do want to point out that there is one exception to this design, which sort of forms a bit of a control. And that's on the right-hand side, the 2 red paths. The shortest route is actually to walk along the creek and then up a quiet residential street. So that's kind of optimal from all aspects. We just chose another route, the dark route, to also follow mostly residential streets as much as we could. We would expect pretty similar exposures along these 2. And, if children can't access the creek or their parents would prefer they didn't walk along the creek for some reason, then that's an alternative route for them. So I'll highlight that in the results. That one does stand out a little bit, but generally the design is that we have a shorter direct path and a slightly longer alternate route, which goes down quieter streets. So, whether you handle instrumentation or not, I think it's pretty important to understand how the data is generated. And we're talking about a new approach here. So I want to pull back the curtain and show you exactly what's involved. So each study participant, as Amanda mentioned, we had 1 walking each route, so 6 every day. Each participant was carrying about $40,000 worth of equipment, and that's what's shown here. So the bulk of that cost is in the ultrafines and the black carbon. We were really prioritizing those. It's about $20,000 each for the ultrafine particle counter and the black carbon monitor. And they are handheld portable devices with a battery, which is what you need for this sort of monitoring. But we have done reference comparisons with them against a condensation particle counter and a desktop atherometer, and they performed really, really well. So I'd say they're near reference grade, while also being portable and battery powered, which is great. The other instruments we brought along were a GPS logger, so we could spatially match all of this information. A sound level meter, as Amanda mentioned, noise is becoming, increasingly important in this research, not just as an amenity factor, but as a health factor as well. Thermal comfort also, we really wanted to see what we could get out of that, because, you know, an integrated approach, if we can optimize these routes in terms of shade and noise and pollution, you know, that's the ideal outcome. And the PM2.5 monitors supplied by EPA, which, as Amanda mentioned, they were being trialed for bushfire smoke monitoring, and we were curious how they would perform in this context, because PM2.5 is a focus for a lot of people, and this is a low-cost device, you know, orders of magnitude cheaper than the ultrafines and the black carbon. So the citizen science potential is huge. Just to throw in some action shots of what it looks like to do this monitoring. That's Amanda in the top left, and me in the bottom right before I cut all my hair off. It's we put the black carbon and the ultrafines in a backpack. That was the easiest way to transport them, and we ran the inlets up on the shoulder, so it was approximately breathing height for us. And the other instruments were clipped onto the backpack or carried on a bar in front of us. If the backpack would interfere with the measurements, say noise, for instance, we wanted to keep some distance there. It's not apparatus that you would give to a child if you were going to do this study differently and have children do the monitoring. You need different instrumentation essentially, but this is really high quality data that we're getting, and the trade-off is that you need research assistants or researchers in our case to transport it. So data quality is a huge focus for me. As Amanda mentioned, we collected over about 32 hours of 1 second measurements. The spatiotemporal resolution of this data is really powerful, but it needs to be treated appropriately. So these are some of the measures we took in the study. So co-location is important. I think in all monitoring studies, we grouped up the instruments before we even started monitoring and ran them for about a day in a controlled environment to see how they perform with each other. And even after each monitoring session, we would set them down together for 20, 30 minutes to monitor the actual environment and see if there's any bias there, because we're using different instruments to measure the direct routes and the alternate routes, and then we're comparing them. So we need to make sure they're on a similar baseline. We then validated the data using whatever instrument diagnostics we have. So flow rates, for instance, we would check everything was in range and discard any data that wasn't. And then I manually reviewed it to validate any outliers, if they're real measurements or not, that sort of thing, pretty standard. But in addition to that, I used a smoothing algorithm. If you've ever worked with high resolution black carbon data or atherometers, you know it's very noisy, even at a 1 minute measurement. So 1 second measurements are extremely noisy, and it was really useful to use this optimized noise reduction averaging algorithm to smooth that out while retaining the peaks in the black carbon. And then for most of these statistics, I averaged the 1 second data sets up to 1 minute, because that's a pretty commonly used period in the literature in these sort of studies. And it just, it sort of cuts down on the amount of data you have to deal with, while also, you know, it's a pretty appropriate time interval given how far you can walk in a minute. But crucially, I also checked that there was enough data in the average for it to be representative of that period, because if you have an instrument error and you are invalidating all but, say, 2 of the measurements in the minute, you then do not want to represent the minute by those 2 measurements, because it could be heavily skewed. After that, I then did apply a slight correction based on the co-location we did to the ultrafine particle and black carbon measurements, because there was a bit of an offset on the instruments from factory. sensitivity check shows that it doesn't change our results by much, but it's a good practice to do. And lastly, in terms of the statistics, you've just got to be aware that these personal exposures tend to be skewed towards lower ambient concentrations with outliers from being close to the source that may be orders of magnitude higher. So non-parametric statistics generally used to account for that. Okay, this is really the meat of the study. I'll go through this slowly because there's a lot on the slide. The map is just a reproduction of earlier, showing you the routes for school 1, and I've added some extra labels there. Next to that is a box and whisker plot of the distributions we measured. So UFP, ultrafines as the top, black carbon in the middle, and noise at the bottom. And then comparisons between the alternate and direct routes. So the box and whisker plot shows the median concentration, which is sort of the most typical concentration along the route as the line. The box around the line shows the interquartile range, and the whiskers go from the 10th to the 90th percentile. So I've had to truncate some of the outliers, the lone dots, because as I mentioned, they can be orders of magnitude higher. And so I've just sort of zoomed in to show what's going on. But then to show the level of skew, I've also got diamonds in the plot showing the mean value. So in all cases, I think, or almost all cases, that diamond is above the median line, meaning it's skewed by some high exposures. Now, the statistics that I'm using to compare the direct and alternate routes is just a difference in medians. So if anything, it's looking at the box plots, it's a bit conservative. You would probably get higher percentages if you compared the means. But the median is, as I said, a really nice representation of what you experience throughout the route. And given we only walked the routes, 3 days of the week, I don't want them to be, the statistics to be skewed by a single vehicle idling or something like that. So across the board, even in the median, we saw significant reductions on these alternate routes compared with the direct routes. I've just included an asterisk to show which ones were statistically significant using a non-parametric test. And so all of them were pretty large percentages and statistically significant, except for just the green routes for ultrafines. It was possibly a reduction, not statistically significant, because there was quite a bit of variation in the results. So maybe some additional monitoring sessions would have rectified that. But big picture, reductions in all of the pollutants simultaneously, and that's great news because it suggests that we can optimize for all of these at once. We don't have to trade off ultrafines for black carbon or either of those for noise, for instance. So really promising results at the first school. And similar results at the second school as well. Generally a reduction on the alternate routes with, I would say, 2 notable exceptions. So the first one is the red routes, as I mentioned earlier. We were expecting them to be pretty similar, and they were. So the percentages were generally small or statistically insignificant. So that's a nice control for us. And one quite interesting exception was on the green route pair. So that's route 2. We found actually higher and statistically significant higher black carbon on the alternate route going down the residential streets. So maybe just goes to show that the way these routes were designed by Bicycle Network, prioritizing safety, doesn't necessarily guarantee that there's lower environmental exposures. When I sort of zoomed in on these results, I found that there were higher than expected concentrations of black carbon on those back streets, mostly centered around road crossings and intersections. They're only small residential roads, but if a car has stopped or is idling and you walk behind it, it has a pretty significant impact. And at the same time, the direct route, about half of the direct route is walking along a pretty major corridor in front of the school going east to west. And I found that on some sessions, the concentrations along that road were actually lower than expected. And the data seems to indicate that that is down to the wind direction. So as Amanda mentioned, wind can be hugely important, even walking along a main road. If the wind is blowing across the road away from you, you might not be getting exposed much at all, versus if the wind was blowing towards you. So that's something that we didn't fully account for in this study, and certainly an interesting direction for the future. Now, the real power of this data, I think, is in the spatial analysis, even using the 1 minute average concentrations as I've presented here. So this is 1 minute average ultrafine particle concentrations at both schools. This is really just fundamentally making the problem visible, which I think is really powerful, and we can start to hone in on some hotspots and what's really causing these exposures, and use that to form guidance for how we can design these routes to avoid exposures. So the color scale here is relative to the highest concentration that we measured in each domain. So it's not relative to any particular standard. As Amanda mentioned, ultrafines aren't regulated in Australia. So it's really just about comparing where the exposures are greatest, rather than trying to get below some level, because, as we like to say, that WHO says there's no safe level for air pollution. So relative color scales, but they do a great job of highlighting the problem areas. So I'll just show you what some of those look like. At the first school, take the northernmost circle, for instance. That is a busy road with a turning lane with cars queuing. So although we're not walking along that road, I saw some pretty significant exposures just crossing that road. So something to be aware of. Slightly more extended exposures in that the second circle down. That's a pretty tight retail arcade with frequently stopping cars, idling vehicles, and there's even a bus stop for diesel buses in there. Not surprising that we saw high ultrafines in that area. And the third circle down was where actually the highest exposures were measured, and that is just a major signaled intersection with a pedestrian crossing. I counted about 22 lanes total at this intersection. It is really massive, and the amount of time that you spend waiting for the crossing signals can be really significant, and that's something we'd like to investigate further, because we weren't timing the signals in this study, but I think reducing wait times can be a really powerful intervention. If we do the same thing at school 2, the northernmost circle again, we saw some pretty high concentrations crossing this. This is a major road, and actually it's a freight route from the Port of Melbourne. So it's quite a dirty road, but there's an overpass which is potentially a good option, although we still saw high exposures crossing that overpass. But the second circle down is a ground level crossing of the same road, and that was even worse. So the overpass is preferable, but school kids were crossing at the ground level intersection as well, which is not great. And then in that corridor that I mentioned all the way in front of the school, we saw sort of moderate to high levels all the way along. That's mostly drop-off traffic in the morning. And what's interesting about this case study is that heavy vehicles have already been banned along that road, and that ban is enforced. We saw it enforced while we were there, but it's still a problem. That's the drop-off and idling traffic. So we can do the same thing for black carbon, of course. It's theoretically more sensitive to diesel heavy vehicle traffic, but in these cases, the hotspots are largely the same, I'd say. We could interrogate this data further because the instrument we used actually measures 5 different wavelengths, and you can use the distribution of wavelengths to infer the source of pollution. So diesel traffic would have a different signature to biomass burning or cigarette smoke, for instance. But because we saw quite a few overlapping hotspots, it just suggests that the hotspots are traffic, and there's a high level of agreement between black carbon and ultrafines. Noise, on the other hand, stands out as really quite different and produces some really tidy maps with some nice gradients to them. So this shows, I would say, the clearest correlation with traffic, because unless there's another source of noise, construction, for instance, what we are measuring is road noise. And the resolution of this data, you can really see it actually in the left figure. There's a road going down to the south, and it transitions from an orange color to red in a really neat gradient, and that actually reflects the speed zone changing from 40 to 60 kilometers an hour. So it's really powerful data, really great for quantifying noise exposures, and in some cases can be a proxy for air pollution, but not all cases, that's for sure. So to wrap all of that up, what these 2 schools, this feasibility study showed us is that certainly alternative routes can provide a significant reduction in trap and noise exposures. And furthermore, from the spatial analysis, we saw that major road intersections and crossings were a key determinant of exposure. So going forward to develop guidance, that would have to factor in. But I haven't mentioned PM2.5 and thermal comfort in detail. All I would say at this point is that those results are inconclusive. For thermal comfort to be relevant, we really need to repeat this measurement in the afternoon. The measurements were quite flat in the morning, as we would expect, but in the afternoon can be really important. And our colleagues at the University of Melbourne have done their own work, which shows that walking catchments can grow significantly in size, even double, depending on the availability of shade on the route. So we want to keep looking into that. And for PM2.5, the instrumentation is to be used for bushfire smoke monitoring, which is a very intense source. And we just found that the sensitivity wasn't there for this particular instrument to measure roadside air pollution, but possibly for other instruments could do it. And it's definitely a promising direction for future research, because the citizen science potential is really significant. And if we could get a large number of people doing this sort of monitoring, then we'd have some great data sets. So we would like to do some more work. We would like to do those afternoon walks, and we would like to understand the effects of weather, especially wind, more, because that could really enhance or attenuate your exposures when walking along major roads. So I will shut up now, and I'll hand back over to Amanda to wrap up, and then we'll take some questions.
Thank you, Manning. So just to let you know where we're at, we have submitted a funding request to expand the study to include 6 primary schools. Some of you may be familiar with the Breathe Melbourne project that's about to launch. And so we would like to include 6 of those schools. And as Manning sort of already pointed out, we really need to think about afternoon exposures, We need to address wind effects, and we also would like to target some of the hotspots as well. Manning will be presenting the data at the Clean Air Society for Australia and New Zealand, which I believe is in September. It's actually a shorter presentation, so you probably get less information on that one, but it may be a bit more finalized at that point. He's also working towards putting a manuscript together for publication later this year. If we do get funded, I think we really need to engage with the community around the future monitoring in terms of their realities and their concerns, and see if we can better understand exposures in that inner west region. We also are keen to sort of evaluate any mitigation strategies and discuss those further with the Department of Transport. As Manning said, time spent trying to cross an intersection, if we could get Department of Transport to prioritize the pedestrian crossings just between 8 and 9 in the morning and 3 till 4 in the afternoon, that means the children are not going to be standing next to that busy road intersection for an extended period of time, and thus their exposures could be reduced. We did think about the bridge crossing, the pedestrian bridge crossing over that really busy road, but to get to that bridge, you would have to walk along that really busy road. So that wouldn't be ideal. So I think this is a few things that I think that we could tease out from this data, and we're keen to sort of progress with more data collection. It is a large group, and I have to acknowledge their support and input. And this was work that I did whilst I was at the Australian Catholic University. I'm now moved over to CSIRO, and will have the okay to continue to support this work. But a wide range of expertise and knowledge, and I think that that's really strengthened the interpretation of the data. We're very grateful to everybody for their contribution, and the instrumentation has been supplied by Department of Transport as well as ACU and the University of Melbourne. So if you would like to get in contact with us, here's our email addresses, and we're happy to take any questions.
Right, thank you so much. So we'll have a look in the chat first, and if anybody does have questions, you can pop your hands up or just shout out. So we'll see how it goes. So let's see. So the first one is from Malvin. So nice talk, Manning and Amanda. Which spatial methods or statistics did you use to identify the pollution hotspot?
I'll leave that with Manning.
Sure. So the most basic visualization, which I've presented here, is purely just plotting the 1 minute average concentrations and their corresponding GPS coordinates on the map, with some opacity so that the darker colors can show through. I just used those maps as the basis for really sort of zooming in on the hotspot areas. That was enough. If you just pick the right percentiles for the mapping, the hotspots show up. And from that, I can then select those points and have a look at the time series and the distributions that are contributing to those points. And from there, just take a mean or a median to see which hotspots are the worst, really. But I am looking at more advanced mapping methods because, for instance, there's a group at Swinburne University headed by Marcus White that is putting together a project. It's an ARC linkage called Walk Quality, and they're looking at all sorts of factors that influence walking and building a system to support that. So they're looking at not only air pollution and shade, but also accessibility, availability of footpaths, gradient, all that sort of thing. And so we're working with them on building a more sophisticated visualization for this.
Wow.
Thanks.
So the next question, so thank you for your project and the presentation. I'd like to know what other possible future research you can recommend. It may be either on the developed cities or underdeveloped cities around the globe. That's a big question, isn't it?
that is huge. But yeah, I mean, I think that, you know, there's so many things that could be done differently in terms of where you locate a school even. And but I think, you know, schools are around for decades. And so what can we do to change exposures for existing environments? And, you know, I think that the growing issue around obesity in children, you know, we really do need to find a way to encourage children to be more active. And so, you know, it seems sensible to make your commute an active one, but if it's increasing your exposures, maybe that's not so great. And so, you know, there's just so many questions. And so, you know, I think for us, it's identifying where those high exposures are happening and trying to find a solution that is implementable.
Yeah, definitely. I wonder if in the afternoon the exposure levels are higher or lower. I'm not sure about how that fluctuates through the day, but I'm really interested into, you know, the next bit that you guys are working on, hearing about that, and if you get more funding, different times of year as well. Because I know here in Hobart, you can see the smoke sitting on the streets. So I don't go running in the winter outside because I can just see the smoke. But in the summer, people aren't using their wood heaters as much, so you don't see the smoke. So it would be really interesting. Yeah, and then communicating that to parents. It's a big task.
One of the pollutants that we're not measuring is ozone, which we know, you know, increases in sunlight and sunshine and afternoons. So yeah, I think the mix of the pollution does change. For the ultrafines, you also get secondary aerosol formation in the afternoons. So there's a lot of things I think that we need to understand better.
Yes, yeah, definitely. Let's see what else we've got in the chat. So very interesting and important piece of research. Has there been ambient monitoring conducted on the school grounds throughout the school day to ensure exposure during the day? Or to consider exposure during the day, I mean.
Yeah, so we, EPA Victoria are doing some continuous measurements of PM at one of the schools, but not the first school. And so I think going forward, we would like to ensure that we have that information for all of the schools. We didn't seek approval from the schools to do this study. We didn't go on the school grounds. So it was really just a walk around. And that's why we've been very careful not to say where the schools are, because we don't want to make life difficult for them, but this was just a feasibility study for us.
Mm-hmm. Wow, great. And we've got another one. They've got lots of questions. That's wonderful. Manning, you touched on person exposure level versus ambient concentration. Can you expand a bit more on that? Specifically, I'm curious to know if the levels you found differed to ambient levels measured through the government sensors.
Yeah, it's a good question, Suki. Unfortunately, the EPA regulatory network doesn't monitor ultrafines and black carbon. So when I refer to ambient levels, I can only really refer to the ambient levels we measured, either formally or informally. So formally, we measured background levels by placing monitors at the school while we walked. Depending on where that was located around the school, we couldn't go on the school grounds. It might still be a bit close to a road to be considered ambient, but it's close to. And the other indication we get for ambient levels is when we're walking on the back streets and we're not near a source, essentially the minimum level that our monitors drop to. That's really all I can say in terms of ambient. I would love it if we had a network of these sensors, and it is something we're working on in the Department of Transport. But compared to the ambient levels that we measured, these exposures near the road are very high. there's plenty of publications on the actual shape and magnitude of that curve as you get away from the road, but can be, several times to even orders of magnitude higher than background when you're near a vehicle.
And then here's another one from Kate. In the UK, there is a significant community advocacy movement to have school streets. The entry streets to schools cleared of traffic, particularly at arrival and departure times, to reduce idling outside the schools, which is also impacting inside school buildings. Have you considered this issue?
Yeah, so I think there's been a few anti-idling programs, and yesterday, Manning, you were telling me about a project, and I'm trying to remember where that was located.
So actually, this is very relevant because yesterday I spoke with someone in government who is involved in planning where new schools go, and she sort of enlightened me on a lot of the trade-offs and sort of competing benefits in that space. And at one particular school in Melbourne, they made a conscious decision to include no drop-off zone. So there was, you essentially had to drop off further from the school or actively commute to school with your kids. And that just didn't work for them. Cars were still pulling up in front of the school, idling, and they eventually had to concede and assign a 5-minute parking zone. So that was, that was kind of enlightening yesterday and a bit depressing.
Yeah, my goodness. And then I think we've got another question. Oh, we've got a few more. Good. From Ellen. So in relation to the monitoring of bushfire smoke, the health impacts and minimization of exposure, what can individuals within the community do to decrease smoke pollution? Oh, and she's talking, I think this might be, oh yeah, you guys can try and answer that one. Yeah, she's talking about the Hazelwood Health Study. Yeah. So what can individuals do to decrease smoke pollution?
In their commute, or?
Yeah, I think in their communities is the question. Is that correct, Ellen?
Yes, that's right.
So
in communities.
Yeah, like within our local community.
From things like wood heaters and things like that.
Yeah, basically.
Okay.
Yeah.
Okay. So when you're outside, or just in like
just in general. Basically, I don't know too much about it, so I was just wondering what the sort of general consensus is.
Yes, yeah, well, that's a bit of a can of worms too.
Yeah. So I think, if there is a smoke event, the usual guidance is to stay indoors and keep your doors and windows closed, and more frequently, I think guidance is being provided in terms of using portable HEPA cleaners indoors to try and reduce your exposures. Also, you can wear the N95 masks if you can fit them properly, but also that you could not exercise outdoors during these events. So there are a range of guidance recommendations from Department of Health and EPA for pollution episodes, and obviously if you're a vulnerable individual, then I think that some of those are still relevant for background chronic exposure to traffic. So those things could be considered as well.
Another document you could look at, Ellen, is the car election priorities, because it talks a bit more about where wood heaters can go and changing the standards around them to produce less smoke and burn more efficiently. So you can have a look on the website about that one too. So we've got another one from Kate. In my area, wood smoke from home wood stoves can also significantly impact air pollution on roads. Are you avoiding times of the year when this is an issue? For your school study? Yeah,
so we conducted the monitoring in November, which was obviously quite a warm time of the year, and I think our goal is to try and get out around that same time again. I think we would have an opportunity, as Manning said, with the black carbon to sort of separate out different sources of incomplete combustion with the different wavelengths of black carbon. But I'm not sure that we really want to complicate our story. I think, so perhaps that's, that would definitely make it more difficult, but I think if we need to, we could. But yeah, I think it's definitely an ongoing problem, I think, for many communities is the wood heater issue.
Yeah, definitely. Yeah. Great. Well, I think we might end it there. Lots of great questions. I'm really happy with that discussion. That was wonderful. Thank you both to our presenters for coming and sharing your wonderful work with us today. And hopefully we'll see everybody in about a month's time when we run another one of these. So thank you.
Thank you.
Yeah,
see
thanks
everybody.
everyone. Really good questions and feedback.
Yeah, lovely.